Hello everyone, I'm Sivendra Singh. Today I'm going to discuss a subjective question number 155 from Test of Maths at the 10 plus 2 level prepared by ISI. This is a past year question of ISI B.Stat or B.Math entrance examination, and this question is from limit of infinite series. It's a beautiful problem. In this question, we'll be using Riemann sum to solve this problem. Uh, so we write it as uh, limit n goes to infinity summation of k is equal to 1 to n 1 by n plus k. So this is equal to limit n tends to infinity 1 by n times summation of k goes from 1 to n 1 by 1 plus k by n. Uh, I can write it as limit n tends to infinity 1 by n summation of k goes from 1 to n f of k by n, where fx is equal to 1 by 1 plus x, and x belongs to real number except minus 1. At x equals to minus 1, this does not exist. Where x takes the values in real number except minus 1, because at x equals to minus 1 fx is equal to 1 by 0, and this does not exist. We'll be using Riemann sum to solve this problem, and in order to solve this problem we need to create a partition. So the partition can be as like this is y-axis, this is x-axis, x y, this is function y is equal to fx. Suppose we need to calculate this area of this function. Here we create some partition. Partition is as follows. We divide this region into several rectangle. I mean several form of subintervals where a is equal to x naught, this one x1, and then x2, and this one is xk minus 1, this is xk, this is xn minus 1, right here, xn minus 1, and this is equal to xn. So the Riemann sum, suppose the partition P is equal to a is equal to x naught comma x1 xk dot xn. This is the partition, and xk is equal to a plus k by n, where k runs from 1 to to n. And xk minus xk minus 1 is equal to 1 by n for all k from 1 to n. So the length of each subinterval, the each subinterval is 1 by n. Riemann sum states that if f maps from closed interval a comma b to r is a continuous function, then limit n goes to infinity 1 by n times summation of k goes from 1 to n f of is equal to integration from a to b fx dx. So this means that the area the area of this region uh, is given by the summation of the area of each rectangle. Each rectangle when summed together, this will be given by the area of this function. Okay. In our problem, we have x naught is equal to 0, x1 is equal to 1 by n, x2 to 2 by n, xk is equal to k by n, and xn is equal to n by n is equal to 1. So limit n goes to infinity 1 by n summation of f of xk, right? K from 1 to n, f of xk. And what do we have for xk? Xk is equal to k by n, right? Because a is 0. So a plus k by n is 0 plus k by n. So this is equal to integration from 0 to 1 fx dx. And previously we have already defined fx to be 1 by 1 plus x for x belongs to real number. So we just need to use this, and it is as 0 to 1 dx by 1 plus x is equal to log x d x goes from um, log base e 1 plus x goes from 0 to 1. This is equal to log 2 base e minus log 1 base e, and we know log 1 base e is 0. So this is our answer. But the point is that how this Riemann sum has come. So we next try to illustrate this star equation. For that, we again draw the graph same graph as we have done previously. So what will be the function? Y is equal to f of x. So this was a is equal to x naught. This is x1. This is xk minus 1. Say this is xk, and this to be xn minus 1, and this to be xn. Okay. So we're talking about this thing. And what Riemann sum, what it says that the area, the summation, the total area of the upper area of the rectangle. I mean, whatever the maximum value that this rectangle can take. So this area plus this area plus this area plus this area. I mean the whole maximum possible area that can be drawn within any interval. Within any interval xk minus 1 by xk, the sum of the maximum possible area uh, will be equal to the area of the function fx. Okay, because here, the length of the each subinterval will be 1 by n. So as n goes to infinity, this length will be 1 by this length will goes to 0. So in that case, just take example, the xk minus 1 and x of the length will be so small that we can approximate it to be linear. So whatever the function fx to be, if it is continuous within the interval, we can take it as a linear, right? So the concept is same. This will be approximated by a function f of x thing. Okay, and similarly for the lower Riemann sum, the whole sum of lower Riemann sum uh, in each of the subinterval. So in each of the subinterval, the sum of the lower Riemann sum will be equal to the sum of the upper Riemann sum. Okay, upper dimension is the maximum possible rectangle. Maximum length of maximum area of the rectangle, and lower Riemann sum is the minimum area of the rectangle, and the sum, the total areas. So our function, so our integration from a to b, so integration of this function will lie within the upper Riemann sum and lower Riemann sum, right? So uh, Riemann sum says that is length of partition B, uh, and what is the number of partition? This is n, right? If this n goes to 0, sorry, the number of partition n goes to infinity, then the length of each subinterval, the length of the each subinterval is 1 by n, and it goes to 0. And so the upper Riemann sum is equal to limit n tends to infinity summation of Give from 1 to n area of the largest rectangle in the subinterval xk is equal to the Riemann sum, which is equal to limit n tends to infinity k goes from 1 to n area of smallest rectangle in the subinterval xk minus 1 to xk, and this is equal to the area of fx in a to b, which is equal to integration from a to b fx dx. So this is the basic principle, and from the same principle this result comes. And for the entrance examination we just need to remember this thing, so we can apply this whenever f is continuous in the interval, in the closed interval a comma b, or here it is 0 comma 1. So this is the basic idea to solve this problem, and it ends here. Thank you.